In this video, my friends and I will walk you through our attempt to do an ammonia fountain using household ammonia and a cabbage indicator. So step 1 is actually making the cabbage indicator from red cabbage.
So we have this red cabbage and it works as a natural indicator. The way we make this indicator is we add some water and some cabbage leaves into this blender. We're now straining the red cabbage. This is our indicator, strained.
The next item on our list is a container to hold the ammonia gas in. So the reason why we have this soda bottle is because it's supposed to hold carbonated drinks. So therefore it's able to hold in all the pressure of the ammonia gas we're going to make when we heat this bottle up. So that's our ammonia, and that's a liquid, but we'll be turning it into gas with a hairdryer.
Here's our indicator. Here's our red cabbage that we use. Here's the ammonia.
So here's just a rundown on why we're using a cork and how just the overall setup is going to work.
Cork to block this so that none of the ammonia gas escapes, and so that we make a big enough hole for the straw to go through.
Yeah.
So that the solution can travel through the straw into this bottle.
Yeah, this is where we're putting in the indicator.
La, 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 la. So in the next clip, we're just trying out to see how much ammonia gas we can make out of the liquid. In this clip, we're amazed at how much pressure had built up from the ammonia gas in the seconds we had heated it up. So that's us feeling it.
We just put 20 milliliters of ammonia.
So a brief overview, the reactants are ammonia, which is on top, and H2O with the pH indicator on the bottom. And we heat up the ammonia liquid so it can turn into gas. And then when we heat it up and then we stop heating it up, the temperature goes down and the pressure also goes down, so then it creates a suction for the H2O, which will react.
Once this water goes up here, it'll react, and so then it creates a fountain. Okay, so you notice how the indicator is now blue.
I noticed that, yeah.
So the reason why the indicator is now blue is because it reacted with the ammonia, which is now a base. This picture is when we put it next to a fridge so that the temperature could go down and also the pressure, so it would suction
So
more.
this is our experiment. Actually, nothing happened. Maybe it's because the ammonia percentage was too low, but we put some phenolphthalein and water in.
So there actually was a reaction, just not the full reaction we wanted. The reaction was between H2O and weak acid ammonia, and that's why there was a pH color change, but it wasn't the full reaction we wanted. So we ended up having 10 different trials for this to get it right, and we kept adjusting, and there just was always a problem, so we moved on. The reaction we were expecting was an ammonia fountain, so with the pressure and the suction, it would have created a fountain.
So on the chemical level, when we heated up the ammonia, obviously we had ammonia liquid, so it got rid of all the water, so it was pure ammonia gas, and it was in this. And you could tell because the pressure, you could squeeze this and it was really hard, so that was all the pressure in the container. And then this was just an indicator with water. So when the water reacted with the ammonia.
So in the end, we did get a chemical reaction, just not the full one. I will insert a clip of the actual ammonia fountain and explain what's going on.